Good morning class. In this video I am going to discuss about limitations of Ohm's law that was left. In earlier video, in previous video we have discussed about Ohm's law that was V is directly proportional to I, that is potential difference applied across a conductor gives you the amount of current that will be proportional to how much potential you have applied. अगर आप सेल का नंबर या बैटरी का नंबर या वोल्टेज का पोटेंशियल डिफरेंस का नंबर या अमाउंट इंक्रीज करोगे, so in that pattern only you will get increased or decreased amount of current. तो Ohm's law में क्या था कि temperature and physical conditions need to be kept constant and then only V is directly proportional to I. Why we have written this? Because there are some chances, there are some conditions, there are some devices that show somewhat abnormal behavior as you keep on increasing temperature. Like for metals, non-metals, insulators, semiconductor, they all have different behavior as you keep on changing temperature. Their resistance keeps on changing. So that is why Ohm's law is applicable only up to restricted conditions, only when temperature is kept constant. So any device that follows Ohm's law is called as ohmic device or ohmic conductors they are called as, and those which do not follow Ohm's law are known as non-ohmic devices. Like for example diodes and thermistor that you are going to read in your higher classes, but we are going to do a short part of it so as to complete the limitation part of Ohm's law. So for a normal conductor, VI graph or IV graph is like this, a straight line inclined to x-axis, but sometimes when you keep on increasing temperature, this is for fixed temperature, because for fixed temperature resistance also becomes fixed. But as you keep on increasing temperature, or if the current keeps on passing for a long time, then due to frictional force, electrons, due to heat generation, because if you keep on increasing current, if you keep on increasing potential, current will increase, and due to increased current, heat will also increase. Due to that heat energy, electrons or charged particle gain that heat energy and start vibrating or colliding with each other at a higher rate, which causes resistance to increase. So that is why the pattern of this graph, instead of going this, somewhat deviates from the straight line, and here it shows abrupt pattern in Ohm's law. And at this moment it any conductor, it disobeys Ohm's law. So it's necessary that temperature must be kept constant. So by the time you have understood that why temperature need to be constant. So next is the case of diodes. Diodes are devices that you use in some kind of sensors and LEDs also. Light emitting diodes, you have heard LED, that consists of diodes. Diodes have vast applications, but right now we are not going deep into that. Just see the graph of diodes, IV graph of diodes. See, for this limited voltage there is no current, ideally very little amount of current is flowing, but after a particular voltage current rises, it shoots up literally, बहुत ज़्यादा increase हो जाता है. But और दूसरी डायरेक्शन में अगर हम देखें, डायोड्स के लिए हम क्या करते हैं, दो तरह से बायसिंग करते हैं. एक फॉरवर्ड बायस होता है और एक रिवर्स बायस होता है. वो बहुत डिटेल में है, वो अगर आप कहोगे तो आई विल मेक वीडियो फॉर दैट, अदरवाइज इट्स नॉट इन योर सिलेबस. सो दूसरी तरह से अगर हम करंट प्लॉट कराते हैं तो कुछ टाइम तक बिल्कुल भी प्लॉट नहीं करता और फिर से दोबारा से वोल्टेज के करस्पॉन्डिंग करंट शूट कर जाता है. सो अगर ये समझ में नहीं आ रहा कि ग्राफ कैसा है, तो सिंपली ये देखो कि ग्राफ आपका स्ट्रेट लाइन इंक्लाइन टू एक्सिस ना होकर इस टाइप का ग्राफ है. दैट क्लियरली शोज दैट दिस डायोड काइंड ऑफ small devices, they are disobeying Ohm's law. So this is one case also where Ohm's law is not obeyed. Next is thermistor. Therm means heat and istor word is for resistor. So the resistors which are dependent on heat, or the resistance of some devices that keeps on changing with respect to temperature, are called as thermistor. They also shows abrupt pattern for VI curve. So they also disturb Ohm's law. So they also disobey Ohm's law. Next case is for a special semiconductor material, which is gallium arsenide. This is a compound, gallium arsenide. These two are elements they together combine to form a semiconducting material. See this curve for Ohm's law, IV curve, is very different sort of curve. For this curve, for V1 and V2, here V1 is different and V2 has somewhat different values, but for two different values of potential you are getting a same value. See, this is V1 corresponding to I and this is V2 corresponding to I. So for two values of potential we are getting a same value of current. तो ये कुछ अलग सा ही पैटर्न शो करता है VI ग्राफ के लिए कौन, गैलियम आर्सेनाइड. तो ये तीन केसेस हैं जिसके थ्रू हम बता सकते हैं कि ओम्स लॉ में ऑल्सो गेट डिसओबेड एंड हाउ इट इज़ गेटिंग डिसओबेड. सो ओम्स लॉ हैज़ सम लिमिटेशंस ऑल्सो. तभी हम बोलते हैं कि ओम्स लॉ एक लॉ नहीं है, ये सिर्फ एक फार्मूला है, रेजिस्टेंस कैलकुलेट करने का एक फार्मूला है. वाई इट इज़ नॉट अ लॉ? बिकॉज लॉ इज़ एप्लीकेबल टू ईच एंड एवरी कंडीशन, ईच एंड एवरी सिचुएशन इट इज़ वैलिडेटेड. वो डिसोबे नहीं होता. बट ओम्स लॉ में ये हम गड़बड़ देख रहे हैं. तो इट इज़ नॉट लॉ एक्चुअली, इट इज़ अ लीनियर रिलेशन. दैट्स इट. So by this we have completed Ohm's law. Next time we are going to discuss next article.